All right, welcome everybody. So I'm going to talk about online education. And so I'm an engineer at Google, but I'm also an educator. And here I am in the classroom at Stanford University teaching artificial intelligence. And when I taught this class, I felt like the subject matter was pretty advanced and up to date. We tried to make it that way. But I also felt like the delivery mechanism hadn't really changed very much since the 14th century. This is the University of Bologna, the very first university. And you see, we got the sage on the stage, just like today. We got the textbook. And we got the sleeping guy in the back. And my class at Stanford was at 9 a.m., so I'm very familiar with that phenomenon. Now, over the years, there have been technological advances since those days, and so let's jump ahead to the modern era. By modern era, I mean 1791. In Life of Johnson, Boswell was writing, lectures were once useful, but now, when all can read and books so numerous, lectures are unnecessary. If your attention fails and you miss part of a lecture, it's lost. You cannot go back as you do upon a book. Now, of course, that's true. He makes a good point. Of course, now we do have the ability to go back with the little scroller in YouTube. He hadn't anticipated that. But it's still true that there's a lot of things about a book that are better than a lecture. And so I've done lecturing, but I've also done a book, and I began to think about that. And here's a passage from my textbook. And this is one that my co-author, Stuart Russell, did the first draft. And I said, well, wait a minute, that's not quite right. And then I did a draft. And then I wasn't convinced that was right either. And we had to choose what to put in the book. You're only allowed to put one thing in. And we realized we are the two worst guys in the world to make that choice, because it's been a long time since we were confused about this subject. But we know that the people who would be the best at making that choice are out there, but we just lost the feedback loop. We know that there are students who are buying the book and taking out their magic marker and highlighting the important stuff, and maybe they have a different color to highlight the confusing stuff that they didn't understand, and they're writing notes in the margin, and we're losing all that. And so we said, well, if we can close the loop and bring that online, then maybe we can get that back, and we can have rapid improvement in textbooks. Here's another diagram out of the book, and it took me a long time to produce this. I had to write a program to munge the data and then draw the 3D plot, and then I rotated the 3D plot until I got just the right viewpoint. And then the poor student just gets these raw pixels and doesn't get the learning experience that I got from manipulating it. But I know that there are techniques where you can have all this stuff be running live, and the student could get the same experience I had. So, Hal Abelson, a famous educator from MIT, was visiting Google, and I asked Hal, I'm interested in kind of the theory of learning. What do I have to learn to get up to date? And I expected him to give me an answer of a big pile of books. And instead, I got the best answer I've ever gotten, which was, he said, you only have to read one paper. And that's Benjamin Bloom's paper from 1984 on what Bloom calls the 2 sigma effect, 2 standard deviations. And Bloom says if you do one-on-one tutoring and you do mastery learning, which means you keep teaching until the student actually gets it rather than until the date of the scheduled exam, then you get 2 standard deviations improvement on average. And so you see the chart moves over, and if you look at the midpoint there, it means 98% are above average, almost like Wobegon. And we'll see a little bit later that maybe he was exaggerating a little, and not all the experiments back up exactly that amount of improvement, but the improvement is there. And this struck home, and it seems to make a lot of sense. So one-on-one tutoring seems like a powerful thing. I think back in my life, here I am with my first tutor, my mom, and we're going one-on-one, and I'm learning something there. So I said, can we take that to the rest of the world? But I don't really have the time or transportation to meet with everybody one-on-one. So can I get close to it by going one-on-many? So I began to try to teach in that way, teaching not to one student at a time, but teaching to one video recorder at a time, and then interspersing the rest of the lessons with it. So my co-teacher, Sebastian Thrun, and I said, it's our turn again to teach this class at Stanford. This time, instead of just doing it in the classroom, we're also going to do it online. and we're going to offer it to anybody in the world to sign up for. And 160,000 people took us up on it. And since then, there have been others that are doing this as well. So Coursera is one of the well-known providers, Udacity, edX, this partnership of MIT and Harvard and now other universities. And at Google, we wanted to get into it too. And the first class we produced was with Dan Russell. It was a class called Power Searching with Google. It just taught you how to use Google better. And that worked so well, we were able to throw together a system to do that. Some of the people taken it and liked it, thank you. That we said, well, why don't we take the system that we used to build this and clean it up a little bit and open source it and let everybody use it. So that's what we did. And we called it CourseBuilder. And last week we had the 1.4 launch. So we're iterating through this. There's the URL. You can just search for CourseBuilder, or you can remember that. It's on code.google.com. And afterwards, we have 5 laptops set up here down front, and you can come play with it, or you can do it on your own with the URL. And here are some of the technologies, the Google technologies that we're integrating. So it runs on App Engine. It's not a Google service. It's an open source product that happens to run on a Google service, App Engine. So you download it, you get your own App Engine instance, and you run it. And you can integrate the YouTube and the Docs and Hangouts and Groups and Gmail and account login and everything else. And we got a couple dozen different courses up and running now from different universities and nonprofits, and more on the way. Here's one example from Sailor.org, this nonprofit that's doing a bunch of different courses with us. We just announced this week this launch of another class following up on the Power Searching. There's a course on mapping with Google that teaches you how to use Google Map and Google Earth. And here's just a little bit more of what it looks like. So if you've seen any of these online classes, it's sort of representative of those. But you can have videos, you can have exercises that are multiple choice and you fill in the blank, or other types of exercises. And so this is what the student sees, what the instructor sees when they're making the class. The first version was sort of do-it-yourself, and you had to be a webmaster. Now, with this 4th version, we've got this WYSIWYG interface. And so there's a rich text editor, and you type what you want, and then you can sort of drag in the various components. And then here we've seen dragging in a YouTube video and a Google Doc in line, and an exercise with assessments and multiple choice or whatever. And each of these components, we've wrapped a dozen or so different types. And then we also have an API that describes how to wrap other ones so that you can have your own custom components that you can then drag in. And in one day, one of our engineers put together Khan Academy exercises as a specialized component. So we just showed how to wrap that. And now if you want, these Khan Academies are all under Creative Commons license. And so if you want to create a class, you can just choose the one you want and drop it into your class. So that's where we were with the first version of Power Searching and with the tool that's now available to everyone. And so you can use it as is, and we wanted to do that. And we also wanted to start experimenting to say, do we really understand yet what's the right way to make these classes? And so we did a second version of Power Searching, and there were a couple of experiments I wanted to do there. So first, I wanted it to be more project-based rather than lecture-based. To say, we really want to have the students experience doing stuff, so don't make them watch a lecture and then answer multiple choice. Just get them right into it and say, okay, solve this problem. So the class, there's no lectures up front. It's just a bunch of challenges, and you choose the challenges you want to do. So challenge number 1 says, during the glory days of radio, it was illegal to mimic the voice of the US president. Was there actually a law prohibiting that, or was that just White House policy? And then you're on your own. You can go and try to answer that using Google. Or if you want, you can take advantage of some of these hints. So we say, here's some things you could look at. You might want to look at Google Scholar or Google News Archive, and so on and so on. And for each of these, here was the second experiment I wanted to do, was saying, I think, the first round of these online classes went a little bit too far overboard in using video. And we heard from 1791 some of the disadvantages of video versus text. So I wanted to offer the video and the text on an equal footing and have the students decide which one do they want to consume. And it turned out it was about 50-50, their choices of which one. So if you want text, you get it as text. If you want video, you get it as video. And you sort of watch all these supplemental pieces. You can also say, well, I'm not quite ready to answer this yet. Can you show me an example of somebody solving a similar problem? And so you ask for an example, and here we walk through the steps of, oh, if we had this as a problem, these are the steps we go through to try to solve it. And then when you're done, you can type in your answer, and here they've typed in, I think it was only a policy, and type show answer, and then see the answer, and in fact, that's right, it was a policy. And for a while we were thinking, well, these aren't multiple choice questions. These are almost like essay questions, and so do we need some complicated AI software to judge whether you got it right or not? And in the end, we said, no, we'll just let you judge, because we're not giving you a grade or a credit. So you type in your answer, then you see our answer, and you say, yeah, I got it right, or you say, no, I got it wrong, but that's up to you to judge. And students never even sort of noticed that we weren't giving them a green check mark or a red X mark. They were just figured it out for themselves. And then another thing we had was making it more social, to say, see how others solve the challenge. So you can click through on that, and there's a discussion forum. People talk about the techniques they used. I like this guy here. How did you solve it? He says, I'm a law student, I just know. So not everybody needs Google for everything. Now, I should say that when I got into this, both in writing the textbook, teaching the class, thinking about online education, I thought that my job was access to information. If I put down the perfect information and explain it in the right way, then I've done my job. And I also thought that was true in my job as an engineer at Google. So when I was running the search quality team, I thought my job is when somebody types a hard query like that, the movie in which no babies are born, then in 0.21 seconds, we should give you the answer is children of men. And if we can do that and the other search engines can't, then I've done my job. But then I realized that isn't everything, is just being able to get the answer. And I ran across a quote from Pablo Picasso, who said that computers didn't interest him because all they can do is give you answers. And I think he had something there, that really the hard part is not coming up with the answer. I mean, I'm proud of the work that the Google engineers are able to do to answer so well, but the really interesting part, the part that's really educational, is that somebody was interested enough to ask a question. And from there, the answer is easy. And I saw that when we met with Teach for America. And we had a teacher who was given a 4th grade class in math, 2 years behind grade level, and by the end of the year had everybody up to grade level. So that was 3 years worth of math in 1 year. And I said, well, wait a minute. It wasn't information that did that. They had the same textbook this year that they had last year and that other teachers had and were unsuccessful with. So it wasn't information, it was more motivation or determination. It was this pact that the teacher made with the students saying, look, I'm gonna work really hard for you, and I expect you to work hard for me, and together we're gonna do this. And so that really shifted the way I thought about what the job of a teacher is. So it's motivation, not information. And so the aspect you really need is willpower to work and to succeed. And I thought back to my college days and said, well, what instilled me to get through? Was it willpower? And I said, nah, it was due dates. And so we tried that, and that seemed to help. And so we think we did much better than the classes that are open that you can take any time, right? Because if you can take it any time, you can take it tomorrow. And if you can take it tomorrow, sometimes you never get to it. And we'll talk more about the nuances of that. Then the peer support becomes more important. It's not just can you explain things perfectly, but can you talk to somebody and can you see, hey, here's somebody else who's working hard on this. I think that's part of what college is all about, is that it's a social environment where you see other people who are also studying. Well, they're partying too, and that's part of college as well. But seeing them dedicated to work and saying, I can be part of that community that's working is important. The faculty encouragement was important. So every week we sent out an email, said, you know, congratulations, keep going. And every week I'd get a dozen or so back that says, oh, you know, Professor, something tough came up in my work life and I was going to drop the class, but then I saw your email and I realized I had to go on. And I felt like saying, you know, that was a form letter, right? You do realize I didn't write 100,000 personal letters to each of you, but it works, right? So just that level of human connection, even though it is a form letter, it makes a big difference. I think there's a pride of accomplishment we need to accommodate, this authenticity of this is the real thing, you know, this is a Stanford level class that I'm taking and I have this opportunity to learn this stuff. I think the excitement of being in the early stages of something new was all contributed to why people wanted to do this. And this is just pointing out sort of the depth of the social engagement that people used all sorts of, you know, sort of any social networking site you can see on the web, people were using that to connect with each other. And here I show, they got this from Coursera from one of their classes. This is a timeline of how many people are online. And like all classes, you can see the superimposition of three things. So there's a ramp up at the beginning, and there's an exponential decay over time. Actually, a lot of classes have much steeper exponential decay. I think this is the one that Coursera chose to release, was the one that has the shallowest decay. And then you can see the due dates interspersed, those big spikes. And I think there's still this controversy I haven't quite figured out yet of how important are those due dates. So certainly they do make people come back and they do make them work hard. But on the other hand, they also make people drop out. If you miss the due date, and then you say, you know, well, now I'm not going to get a perfect score and I might as well just give up. So I think we need to think more about what the processes are. So I've talked about these. You can have a synchronous class. That's the in-class Stanford class that meets at 9 a.m. and if you're late, you missed it. You can have these evergreen classes that are always available. The MIT Open class where it's anytime you want to do it, you can do it. But then you miss the motivation of the due dates. Our class we called semi-synchronous, which meant there was a due date every week, but during the week you could interact with the materials at your own schedule. I'd like to get to a model I call the bus route model, which says that there's a schedule and you get on, you start doing the class, but if something comes up at work or at home and you get stuck, you can get off the bus and say, okay, I'm taking a time out now, it's going too fast for me, I have to stop. But then you know at some point in the future there's another bus you can get back on and finish the class. Okay, now the big question, what's learning? One of my heroes and the founder of, one of the founders of the field of AI is Herb Simon, and he reminds us that learning is something that the student does. And I think as teachers, sometimes we forget that. And we think it's something that we as teachers do, and that's not right. Learning only happens in the student's head, and our job is just there to facilitate it. And so I think what that means is it's not how well can I explain it, it's how much can the student do. And so we tried to make our class so that the students were doing the problems first, and then they would get the explanation. We forced students to make predictions, to say, here's a new situation, what do you think is going to happen? And the reason we did that is because we knew from the scientific literature that if students have a misconception of some kind, and you give them an explanation, no matter how great that explanation is, it's not going to dissuade them from their misconception. They're going to say, yeah, I got it. Then you give them a problem and they still do it their old wrong way. And the only way you get them out of that is to say, okay, do it your way. Here's a contradiction. Your way did something wrong. And then they're ready to think about it. So we made them make those predictions. And I got to say, students didn't like that in general. That they said, well, no fair. You didn't give us the formula, right? I could fill in the blanks in the formula if you tell me every step of how to do it. But it's no fair to make me think and do it ahead of time. And I should say, we were also a little bit clumsy in the way we specified things, in that, you know, we gave them these problems. We said, well, don't worry, you know, it doesn't matter if you get it right or wrong. We just want you to think about it. But then in the end, we gave them a check mark when they got it right. And so, people have been drummed in so much to say, well, the important thing is whether you get it right or wrong. And that's how school works. And we had to do a better, we need to figure out ways to do a better job to say, well, that's not the important thing. Playing with the material is the important thing. We like to have experiments with more open-ended problems. It's easiest to do a fill-in-the-blank or multiple choice because we know how to grade those, but those aren't the most fulfilling. And there's been some experiments with peer grading where you write an essay or design a project of some kind and then have several of your peers grade it and average those grades. Turns out that works pretty well. Now, I talked with Hal Varian, who's Google's chief economist, and when he was at Bell Labs, he wrote the textbook on microeconomics. It's one of the standards in the field. And he was there with Richard Hamming, who you may know from Hamming codes and so on. And Hal said that Hamming told him the secret, that the way you write a textbook is first you get together the problem sets and the exams that you want the students to be able to solve, and then you write a book that teaches them how to solve them, right? So I think this fits in well with this idea of learning is doing. And when Hal was explaining this to me, I said, oh, hey, I know that. In software development, we call that test-driven development, right? So you write a bunch of tests, and the tests fail, and then you have to write some code. And so it's the same with the textbook. You should start with a blank textbook, write the problems in the back, hit go, and every time there's a red mark where the test doesn't succeed, then you have to write a chapter or a section of the textbook. So I think that makes sense. I think the one thing you have to be careful about then are do you end up sort of teaching to the test, right? So it only works if the test problems that you've chosen are the skills that you really want people to have, not if they're just sort of arbitrary things. Now, so remember Bloom, right? He was the guy who wrote the one paper that you had to know about. How much do we trust him? Is he right that one-on-one learning is the most important thing? Well, Kurt Van Lane from Arizona State did a meta-analysis of this recently. I think this was from 2011 or 2012. And Kurt says, here's the conventional wisdom. The conventional wisdom says, Bloom claimed that you have this human tutor, you get 2 standard deviations of improvement. If you have a intelligent tutoring system, the sort of state-of-the-art computer system, you get 1. And if you just have the paper and pencil fill-in-the-blank type thing, you get a quarter or so. And that's sort of what's in the literature, or the sort of expectations that people have. But he looked very carefully at every study he could find and averaged them all out and found out it's not quite like that. That you don't always get these 2 standard deviations of improvement. And in fact, the good computerized systems are doing just as well as a human tutor. And the other thing he found is that it wasn't so much the one-on-one tutoring. The more important part was the mastery learning. So mastery learning, again, means you keep on learning until you've got it, which seems the obvious thing to do. But mostly we don't do that because we've got a whole class of 30 or 50 or 200 students or whatever, and we got to move ahead at a certain pace. So we say, well, you're going to learn this for this amount of time, then there's going to be a test, then we're going to do the next subject. Salman Khan talks about that. He says, this is crazy, right? So this is like if I was teaching you to ride a bicycle and you ride for a while and you keep on falling down, you'd say, okay, great, now we're going to learn unicycle because it's time for the next unit. That wouldn't make sense, and you wouldn't learn to ride a bicycle that way. But if we kept at it until you stopped falling down, and then with the sufficiently large box of Band-Aids, everyone would get it. And that's what we need to do for education, is let people take their own time until everyone gets it, and then you can move on to the unicycle. So I think that those are the interesting lessons from that. And then there's one more lesson that I thought was fascinating, is that so there were a couple dozen studies out of all we spend in education. There was only a couple dozen studies that went into this meta-study, and sort of the canonical one, the one that people cite the most, has 33 students in it. So it's like, we're deciding the future of our education based on 33 people, and maybe 10 of them had a bad day and we got the wrong conclusion. But now we have the capability, when we bring the stuff online, we can base things on 33,000 or 33 million rather than just a small sampling. We're able to collect more data and get more feedback from it. So I think that's exciting. So the question then is how do we get the advantages? So we know, we can argue about exactly how much, but we know one-on-one tutoring and mastery learning are important. Can we get them without having to hire a private tutor for every student? Is technology the answer? Well, technology has sort of always been the answer, right? So all these technologies listed here, movies and radio and TVs and so on, we're going to solve the education problem. And one of the earliest examples, but besides the 1791 example, is this is Thomas Edison, featured here with Eastman from Eastman Kodak. And in 1913, Edison said that books will soon be obsolete in the public schools. Scholars will be instructed through the eye. It's possible to teach every branch of human knowledge with the motion picture. Our school system will be completely changed inside of 10 years. And you can take that last sentence about the 10 years and apply it to every technology since then. And the question is, are we now at a point where anything is any different? Or 10 years from now, are we going to say, well, that didn't work, and now there's a new technology, and that'll work 10 years from now. So what's different? Well, if you look at these four characters and say, what do they have in common? There's probably two answers that you come up with, that we've all been involved in these online classes, and we're all involved in artificial intelligence. And I think there's something about that this idea that you can learn from large amounts of data naturally sort of attracted all of us to say, this is an application where we can take that data and apply it and maybe make rapid improvement in education the way we have in other fields, like computer vision and speech recognition and so on. We've seen that now is the time when it's ripe. We've gone from having speech recognition that's pretty crappy to speech recognition that's now pretty good. And it didn't really take a single breakthrough or a new theory. Most of it was driven just by having better data. Now, here's the traditional model of data. What you get from your 4 years in college is a transcript that looks like this. And that works out to about 20 bits of information per year. Now, here's a consumer electronics device. And that's about 192,000 bits per second. So that's about 1 trillion times more. You also notice that the one on the left costs more than the one on the right. So the bit rate per dollar is about 1 quadrillion times better. So it seems like we should be able to do better than the transcript, right? So we should be able to gather more information, have a better picture of you as an individual, both to represent you to a prospective employer and so on, and also to aggregate that information across all the students so that we can make rapid improvement in the pedagogy itself. Now, if you've seen other talks I've given, this is a chart I show where I say, in lots of application that Google comes up with, in search and speech recognition and image recognition and so on, we often have a response curve that looks like this, where we say we apply some algorithm to a problem and you give it a little bit of data and the algorithm's performing pretty badly, but instead of giving up and going home, you go out and gather more data and all of a sudden the algorithm starts to get better. And the hope is that education is going to turn out to be like this. And we haven't cashed in on that hope yet. We're just getting started. Nobody knows if it's going to work or not. But I think this is what we're all fighting for. Now, last thing I want to talk about is how you put together a class. And this also is from Coursera, and I asked them, what's your most complicated branching structure? And they said, well, we got a genomics class that's got these main components, and then there's a sort of introductory class that feeds into that, and an advanced class that follows up on that. So, you got on the order of a dozen or two units that are linked together in this complex graphing structure. Now, compare that to this graph. Can you all see that in the back? Is that all clear? You can read those labels. So this is from Wikipedia, and this is all the mammals in Wikipedia. So about 7,000 entries and a dense link structure between them. So very different than the other graph. But in some sense, that's not ideal either. I don't want to just, if you want to learn about mammals, I don't want to just give you that. I want to give you some guidance through it. And so what I would like to do is be able to combine these two models to say, what we really need is some guide from a teacher, some pathways through this material. And here I've shown 3 different pathways, 3 guides that says, here's one way to look at this material. And it's a branching structure. And now you have a choice as a student. You can say, I could choose the guide I like and I could stick with them and follow them along the path. Or maybe I can switch to another guide if I find I don't like that one, or if I want more than one point of view. And if I want, I can go off-road. I can say, well, the guide's taken me this far, but here's some interesting stuff that's off the path, and I'm going to take a diversion and follow off the path and on into Wikipedia. So I think we want to build a system that allows that. Now, the problem is, who's going to build it? And I want to make an analogy of something I call courseware engineering to software engineering. Now, in the early days of software, systems were built by small teams. Here we have one guy, this is Bernstein, working on his chess program. Here's Wozniak working on his operating system. And in those days, one guy or a small team could build an operating system. But those days are gone. Now we want to build more complex objects. And we worked out a system of software engineering so that a team like this, these guys built a video game. We know how we can get teams of dozens or hundreds of people to build something bigger than one or two people can build. But in education, we're not doing that yet. Courses are still built by one or two people at a time. We want to find a way to be able to put that together. So, what's this doing here? Well, in some domains, the artisanal product is what you really want, right? So I want a master cheesemaker to be making me my cheese by hand, and I don't want the mass-produced product. And courses are like that, and I want to maintain the best part of the courses of saying, here's this expert teacher, they have years of experience, I don't want to lose that. On the other hand, there are other domains where the mass-produced product is better than the individually produced one. And I want to allow us to do that as well, to be able to say, can we combine these experts and have them build something so that we get the best of both. We get this large graph, but superimposed on top of that, we have the individual expertise. And that's where we're trying to head for, is to allow for that. Now, we built CourseBuilder, and it's a tool that allows you to experiment in building your own class. I don't know how long it's going to take to get here, but that's why I'm in it. And so I guess we got 8.5 minutes for questions. And then afterwards, this is the last session, so you can stay as long as you want. And we've got some laptops set up here where you can play with CourseBuilder, or you can talk to us after. So if there's any questions, you can make your way to the mics.
Hi. I was wondering if you believe that this revolution will start from the academic level or from children in schools, which is another direction that's being...
Yeah. So I think there's a lot of different directions. Now, so I started with the college classes because, one, that's what I have experience with teaching. Two, the sort of subject matter is a little bit more well-defined, so it's, I think, easier to measure. And three, there's no complicated laws with children that are under 13 and getting permission and all that kind of stuff. So it was easiest to start there. But I think you're absolutely right that there are other applications as well, and children is an important part of it. And I think there'll be a mix there of coming at children through the schools and coming at the schools sort of with children discovering it on their own. And you're seeing that with things like Khan Academy, where there's some places where Khan is the official policy of schools and they use it, but there are many more places where kids just say, my teacher said something confusing today and I didn't get it, but I think it had the word binomial theorem in it, and so let me see what Khan has to say, and that will be more clear. So we'll see that, and then we'll also see other uses, right? So we'll see on-the-job training, I think will be important, continuing education, and I think we'll see non-academic subjects. How do I fix my toilet when it breaks? We'll see better education for things like that as well.
The magic of YouTube. Thank you.
Hi, my name is Michael Richardson. I work with AZ Prep. We're an educational company, and our emphasis is actually on standardized testing and the scoring aspect of it. And I'm trying to move us into the digital age and get away from the paper aspect. But traditionally, there's been a challenge there where testing on the computer is seen as being very different from testing on paper. Do you, based on your experience, do you see that continuing to be an issue with the generations that are coming up with the computers and the tablets the same way it has been in the past, or do you have any words on that issue?
Yeah. So that's a good point. I mean, I think you want to be fair to everyone. You know, you don't want to disadvantage someone by saying you have to take this test using technology that you're not familiar with. But you know, I think the technology that we're also already using of filling in little bubbles on a piece of paper, that's not a very natural thing for people to do, right? That's something that you had to learn. And so I think replacing that with learning to use a computer is fine as long as everybody has access to training for it. And it's not, you know, you're ruled out because you've never seen a mouse before. I think maybe tablets have a smaller learning curve, and so that mitigates that to some degree. And you'll just start to see more and more kids growing up and being more familiar with the technology, and they'll think it's odd to be using paper and pencil rather than being using computers.
Hi, my name is Dario from Argentina. My question is related to children. Besides the legal problem that dealing with small children, do you think there is a different paradigm of education? Because on university, you want to learn the thing that the teacher wants you to learn, and it's more like a guided. There's a lot of things to learn, but it's more like a path, a definite path for the learning. In children, I think it's more like knowing the world. And there's experiences with ungraded classrooms and self-guided learning. Do you think it's a different paradigm of learning that can or cannot be covered with this kind of infrastructure for learning?
Yeah, I think that makes a lot of sense, that in a college class, we're able to break up the world into curricula in a more well-defined way, whereas for younger kids, I think you expressed it well, that there's lots of directions that they could go in, and it's not that every kid has to follow the same path. And that's part of the reason why I want to have the tools to be able to build up this stuff. I think it would be a shame to show a kid, you know, use this online tool and there's only one linear path through it and every kid has to follow the same path. I think that doesn't make sense. I mean, maybe it makes sense for differential geometry, but it doesn't make sense for a kid. And so if you want to give them that, it's got to be more, you're giving them a playground that they can explore in. And it's got to be this, you know, dense graph-like thing where they can go in the direction they want. And I think also that, you know, we want to think of this as being a tool. It's not like it's a replacement. It's not like, you know, they don't have school, they don't have teachers, they don't have anything else. They're just stuck in front of a screen. And it's like, this is one more tool. And they have, you know, books and finger paints and everything else they have in the classroom. And this is one more thing for them to play with part of the time, but not the only tool.
Hi there, my name is Jerem McDonald. I'm the Director of Digital Humanities at Brigham Young University. And myself, growing up with technology and being in the development world as well, a lot of what you talk about makes sense, but having academic training in the humanities and working with humanities faculty on a regular basis, I encounter a lot of general technophobia anyway, and over the past year and a half as we've been discussing issues of the types of things you're talking about, there's a lot of resistance we encounter among literature professors of art, history, and so forth. And I was wondering whether from your personal kind of outlook and paradigm, or even from actual experience, what sorts of things you might have to say in terms of the ability to handle the types of problems that humanities education is dealing with, specifically literature and art and history.
Mm-hmm. Yeah, so there certainly have been classes that do that have worked out well. I think it's required a lot of work on the part of the creators of the class in order to do that, right? So it's much easier to do a math class because, you know, I can generate an infinite number of subtraction problems for which I know the right answer and generate them randomly and test students and get that right. I can't do that for an infinite number of essay questions. So the social structure of the class is different. It has to not just be you watch something and then you fill in the blank and it's automatically graded. Rather, it has to be you're collaborating with other people, you're talking with them, they're grading your essays and you're grading theirs, and you're having discussions, and sort of the structure of the class is more complex, but I think it can be done. And I think there are advantages to doing that, that you can have more immediate feedback that way, and you can maybe reach more people, right? So it's, you know, the paragon of liberal education where you have a small seminar with an expert teacher and 10 students at a time, that's great, but it's expensive. And if we can get close to that, but be able to do many more than 10 students at a time, I think that's something worth considering.
My name is Wyatt Anderson, and I work for an education company. I'm not an educator, but I've been told by some that learning is most effective when directed by experts. I've been inspired by Coursera's talks and by everything else that we've seen at Google with regard to the social space, and we're trying to integrate more of a social experience into our learning. And I'm wondering, what kind of challenges do you see with when you integrate a social experience into this sort of like online coursework system with regard to the efficacy of the course, and how do you do you think it's possible to what benefit to the effectiveness of the education do you see that that sort of social interaction with your peers providing? Do you think that's a valid direction for education?
Yeah, I think we still have to understand how best to use these social interaction. So, I did my class, and I go on the discussion forums, and I say, oh, wow, this is so great, because students are asking questions, and I thought I'd have to log on and answer them, but before I can even log on, somebody else has answered them, and they've given a really good answer. And so it seems like a very lively place and a lot of participation. So that seems very satisfying, sort of, until you do the math. When you say, out of all the students in the class, how many are participating? And you see, well, it's only 1% that are doing a lot, and then another 5% that are doing a little, and most of them are doing almost nothing. So we've found a way to be very effective for a small number of people, but it doesn't yet serve everybody. And I think we're experimenting with different things. So there's a trial we're doing with Coursera now to assign students into smaller study groups. So the one large discussion forum is great if you have a question at 3 in the morning, somebody's likely to be able to answer it in a few minutes. But it's also nice to say, well, you're assigned to this group of 10 people, and you're a study group, and every week you're going to have a hangout, and you're really responsible for preparing and showing up there. And you feel much more pressure to show up and perform when you're one of 10 people than when you're one of 10,000. And there may be multiple sizes of groups in between that we need to experiment with. I think we don't know yet what works best.
Thank you.
Hello, my name is Lasnutson. I come from a company called It Knows. We're currently building a virtual science lab / tutorial system for developing countries, especially targeting rural areas where they have no internet connection and nothing. So we have built a system that is online, it works online, but it also has to have this sort of proxy mode, a small box, a Raspberry Pi based, that works in these areas that have absolutely nothing. Now, I know that in Google, offline is probably a swear word, but is there anything in the education initiative to focus on those rural areas as well? Because this is all fine, but we have a huge group of people that have no access to everything you've been talking about.
I think that's a good question. I think most of the time Google's policy has been, we're inventing the future, so we're imagining a future where everybody has connectivity, and we're building towards that, and if we go in that direction, eventually it'll come. We're skating to where the puck is going to be. I think we should keep following that, but I think you are right that there are places now where people don't have that connectivity, and it'll be good to help them. One of my guys on my team just spent some time at the South Pole, and there are times of the year when they lose connectivity because there's no satellite overhead in the right place. And he said, wouldn't it be great if I had a Google appliance on site that could then serve as a proxy for everybody locally. And that would be a good product for people who lose connectivity, but we haven't built that yet. So I think we're experimenting with that. There certainly is a lot of stuff you can put on tablets and so on and pass those around. Alfred, did you have something to add?
So Google.org is focusing on a few major activities, and one of them is trying to provide better access to telecommunications. So that's something that we're really interested in, because you're right, that without telecommunications, it'll be a big problem, and it's hard to come up with specialized solutions for areas that sort of, when it's not commercially viable, right? Just do something special for some area. It's not going to work so well for them. So we're much better off if we can find a way to get telecommunications. So I think it's more feasible than not for large parts of the world now, and we're working on it. Some of the things we've even learned with Google Fiber in the States and doing these things cheaply are actually fairly relevant.
Thank you.
Hi, I'm John. I'm just a developer who's interested in this sort of stuff. So one of the things that you really seem to focus on is the general, state of educational, books, software, etc. But it kind of is apparent, especially from like the Coursera graph you showed, that the motivation you're creating for people is really artificial, just making due dates to kind of keep them compelled, as opposed to making the information that they're learning really interesting to the individual and motivating them. Have you guys done any work on just kind of trying to create problem sets that appeal to just general groups of the populace in order to motivate them that way, instead of just kind of making them, guilt-tripping them into, guilting them for not learning more?
Yeah. I mean, I don't know if guilt tripping is really the right way to look at it, right? Because this is something that they want to do. It's just a question of exactly how do they do it and how do they fit it into the rest of their life, right? So we're not forcing them to do anything, right? They haven't paid any money for these classes. They could drop out at any time. So the fact that they don't drop out means this is something they really wanted to do, but they needed the motivational structure to figure out when to do it and when to fit it in. And the benefit of having the due date is now when you go into the discussion forum, you get an answer right away, because everybody else is online working on the same thing. And so I somewhat sympathize with this idea that it's a false motivation. But there's also a real motivation of camaraderie, of saying, we're all in this together and we're doing it right now. And I think that part is genuine. Now, can you have it so that we don't need any of these dates and people just want to come back and do it on their own? And people talk about that. There's talk about gamification. If people are so excited about playing video games and they don't need due dates to play a video game, can we do the same for education? I think that's worth trying to understand better. And people talk about putting in all these badges and points and so on, and people get motivation for that. That's a little bit different than due dates, but it's also external rather than internal. I think the reason people get excited by video games is because they're doing something that's epic, right? So it's not that you get the badge; it's that, hey, I saved the world from aliens. How cool is that? Now, yeah, I do realize they weren't real aliens, but it's the fact that I participated in something great that keeps me coming back to want to play the video game. I think we have to make education like that. And I think part of it is having them do real stuff, right? So I said education is about you doing something rather than listening to something. And if we make you build something cool, then I think people will want to come back and do it. I think they get turned off when they say, I have to answer a question about this train's going 10 miles an hour and the other train's going 20 miles per hour. And when I'm done, I haven't accomplished anything. I know everyone's done that problem before, and I'm not proud of having done it. But if we can give them things where, hey, at the end, hey, I built something that's really cool that I can share with my friends and that I can be proud of having built, then I think you'll get people coming back for the intrinsic reason.
Hello, my name is Josiah. I work as a professor at the University of Paris. Aren't you a bit afraid of something? The humanity has proven to be able to keep books on shelves for hundreds of years. And it has also proven to be able to lose, for instance, the source code of Emacs 40 years ago. Aren't you a bit afraid to see all this material lost? And maybe with this kind of tools, we are building a new great library of Alexandria that is bound to disappear with all those wonderful things that has been lost.
Yeah, so that's a great question. Now, of course, the Library of Alexandria didn't fare so well either, right? So centralizing all your paper in one place is not a good strategy. Yeah. So it's better to have it decentralized and stored in many places. It's also good to have it stored in a format that's going to persist. And so why would this fail to persist? Well, one reason would be that formats change, right? So it's on whether it's a physical format, it was on a USB drive, and we've moved on and we don't have USB drives anymore. That would be a problem. I think that's becoming less of a problem as we have these cloud services and things are reproduced everywhere, and you don't worry so much about the physical format. So then it becomes more the data format of, is this going to, have standards going to change, and JPEGs or movies or whatever are no longer needed. And I guess there you just need documentation of past standards that will live for a while. I don't know if the JPEG standard is going to be used 100 years from now, but I'm pretty sure if 100 years from now you gave me a JPEG, I could find the definition of what it was like and write a translation program. So I'm not so worried about that. And then the other thing to worry about is the end of civilization. If there is no electricity, then I can't run this program. Whereas the paper stuff would probably still persist. And I guess we should worry about that, but if that happens, we got bigger problems to worry about.
Thank you.
Hi, my name's Dylan. I used to be a teaching assistant at Tech for a really long time, teaching computing to engineers or people who weren't specifically in the study of computing. And you talked a lot about how we can use computing to make education better, but what are the things we can do to make education of computing better, especially in our younger age groups or with female demographics?
Yeah, I think there's a lot of efforts there now, and I guess keep experimenting is the right way to do it. We want to figure out what works, figure out, are there things that are intimidating certain groups? Are we doing things wrong so that we're excluding part of the population? I think, also some of it is that it's just hard. I ran into Don Knuth recently at an event, and he had famously said that he thought that only 2% of people could be programmers. And I asked him if he still thought that, and he said yes. But I think, maybe his standards are just too high, right? Because, if you think of, well, how many people can play the piano? Is the answer 2% or is it something else? Well, it depends on what you mean, right? So I can play chopsticks. Alfred can play the piano well, and and other people can be a symphony player. And where do you draw the line between who's a piano player and who isn't, right? And so I think we can get a lot more than 2% up to the sort of core competency of, yes, I can bang out a tune, even if I'm never going to be a professional at it. And maybe we should put more of our focus on that rather than just saying, how can we hire more people to have this as a professional job? I'd rather focus on, can we get more people having a basic understanding so that they can apply that to the rest of their life? And there, I think it's got to be a lot more than 2%. I don't know if it's 50% or 80% or 95%, but I think we can get most of the people there. And I guess we're going to have to stop now. I'm sorry, we don't have time for more questions.